Hey guys, it is Storvik. We're going to talk about two-way tables and probability today. Boom. All right, let's get it started here. So the first thing I like to do, this is an example of people that buy yogurt at Dairy Queen right here, is I like to go ahead and make a totals column. And that's just me, total here, totals, and totals there. So 23 plus 19 is going to be 42. And then 45 plus 13, 58. And you can add those up too, and when you add those up there, you get 100. So this is going to be your total. Big total. 23 plus 45, I know that's 68. And then 19 plus 13, that's going to be 32. And when I add those up, I get 100. So that's just going to help us a little bit when we go ahead and do this next part. How many people were surveyed? Well, there's 100 in all. And then it says how many people over 50 were surveyed. So over 50, we're going to go all the way across, and that's going to be 58 people. How many females were surveyed? So we go to female here, and we go all the way down, and we see this 32 females. All right, I'm going to be scrolling back and forth to talk about this here as we do the probabilities. It does kind of stink. I got to go back and forth, but that's okay. So a customer from the survey above is chosen at random. Write the following probabilities as decimals and round to the hundredth. So we want the probability of choosing a male. So we add up all the males, and we get 68 out of 100. When I take 68 and I divide it by 100 on the calculator, I get 0.68. You don't even have to worry about the hundredths because that's what you get when you put it in there. On this next part, you want male, and it has to be over 50. And by the way, I want to pause for a moment and tell you that if you need to pause this, if you need to go back and rewatch part of it, do what you need to do to learn the material in the video, okay? I'll probably go a little fast. Just pause me. Male and over 50. So and means both. So not only does it have to be a male, they have to also be over 50. So in our case, that's going to be 45 that are males and over 50. So 45 out of 100, which is 0.45. I will tell you that if you do it on the calculator. Then we want the probability of being over 50. So going up here, over 50, we look at the total here, and it's 58 people. So 58 people out of 100 are over 50. So you have a 0.58 chance choosing someone at random. Then it says male or over 50. So we want all the males and all the people over 50. So or means you could have either. So they could be male or they can be over 50. So they can be male or they can be over 50. So it looks like to me there's going to be 68 plus another 13. So 68 plus another 13. And when you go on the calculator, watch out, some people double add stuff there. Just be real careful. This is going to be 81 over 100, which is 0.81. All right? On the next part, female and over 50. So not only do they have to be female, they also have to be over 50. So female and over 50 is going to be 13 right there. So 13 out of 100, and as a decimal, 0.13. Then we've got a female or male. Now think about it. What's the probability when I pull someone out of here at random that they're going to be a female or a male? There's pretty much a 100% chance of that happening. So when you divide those as a decimal, that would be 1. Female and under 50. So female and under 50. It's going to be 19 right there. It has to be the same exact thing, female and. So 19 out of 100, so 0.19. Female or under 50. So all the females combined with all the people under 50. All the females combined with all the people under 50. All the females combined with all the people under 50. So it's all the females, which is 32, and then also another 23 people. So 32 plus another 23 people out of 100. So this is going to be 55 over 100, so 0.55. All right, remember, if you need to go back and rewatch, do what you need to do. Let's try making our own two-way table. One thing, like I said, is I like to write the total on both the top and the bottom, I think it helps. It says you randomly surveyed students in the school about whether they are attending the big homecoming game. You surveyed only juniors and seniors and found that 42 juniors plan on attending. So juniors attending is 42. 77 seniors plan on attending. So 77 attending right there. And then it says there are a total of 106 juniors. So a total of 106 juniors. And then it says 114 seniors were surveyed, so 114 goes there. So how do we find out the people not attending? All right, well, what you're going to have to do is take that 106 and subtract the 42. And when you do that, you get 64. And to find the number not attending here for seniors, you would do 114 and subtract out the 77. 114 minus the 77, and you would get 37. And you know me, I said I like to make the totals here, so I would go ahead and add everything up, and here we get 220. When we add this here, this would be 119. And we add this here, 7, 8, 9, 10, 11, 101. And that's right, we get 220 in both of our total columns. So then we're going to use this to do the probabilities down here. What's the probability of being a junior and attending the game? So junior and attending has to be both. So 42 out of 100. Now it doesn't say what we have to round to, so I'm just going to show you all of them. First thing, if we had to give a reduced fraction, I would have 21 over 50. If I had to do a decimal, it'd be 0.42. Oh, I did that wrong. Let's back it up. It's out of 220. What am I saying? So it's going to be 42 out of 220, math enter, so 21 at 110. So if they ask you for a fraction, that's what it's going to look like. If they want a decimal, this is 0.19. And then if I move the decimal over 2 places, I'll have my 19%. Okay, so let's look at the next one. Senior. So the total number of seniors here is 114. So 114 over 220, go into the calculator, type it in, and then hit math enter, and it's 57 over 110. And then we also want to look at our decimal, and it was 0.518, so that's 0.52 when you round, so 52%. On the next part, a senior or not attending the game. So a senior or not attending the game. So we're adding these up. So that's 114 plus another 64. 114 plus another 64 out of that 220. So 114 plus another 64 is going to be 178 out of the 220. And then we do 178 divided by 220, and we hit math, enter, and that's going to reduce the fraction to 89 over 110. Now, if we go on the calculator and look at the decimal, 0.809, so 0.81, which would be 81%. Then senior who is attending the game. So senior that is attending will be just 77 there. So let's go down here. We'll have 77 out of 220. If I go on my calculator here, let's see if it reduces. And I get 7 over 20. And if you notice, the decimal is just 0.35. So nothing to round there, and we just have 35%. Ta-da! Well, I hope that this video was as great for you as it was for me, and I hope you had a blast. Until next time, bye!